Hello. Hello, good morning. Please, if you can hear me, can you please give me a thumbs up? I need to, can you show a wave? Oh, thank you, Mrs. Akinyosoye. Good morning. Thank you for your patience. So, are we good to go? I can see only 9 participants. Mrs. Akinyosoye, what do you have to say about the number?
Mrs. Ade, it's actually Adeshewa that's showing Mrs. Akinsola.
What kayo? I think that I'll pay you back. So the guy can market niya. I think that can open at each gate. Kaya po.
Good morning, everyone. I think will just have to start. So this is welcoming you to our webinar on teaching for conceptual understanding and fluency in numeracy. I hope can you hear me? I hope you can hear me. Please help me with the fan. Help me switch off the fan so that's Our focus today is to master the CPA approach. So our focus today is to master the CPA approach, conceptual understanding, and fluency in numeracy. We are going to explore practical classroom strategies today. We are going to strengthen our mental mathematics skills and apply consistent calculation policies across all grade levels. To begin, we need to do a quick chant together. So when I say show it, you say after me. So whatever I say, you repeat after me. Show it, draw it, explain it. Show it, draw it, explain
Draw.
it.
Explaining.
Good, thank you. Now today's focus. All right. Our agenda this morning is simple but powerful. We are going to take a deep dive into the CPA model to know exactly why the CPA approach and to know how the CPA approach bridge the gap from concrete to abstract. And we're going to explore some practical classroom strategies for immediate implementation and talk about how to strengthen mental mathematics. As you can see on the slide, deep understanding, the CPA brings about deep understanding, not just memorization. It builds confidence and fluency, and it prevents misconceptions. Look at the example. A, a year two child is learning subtraction. Who is learning subtraction? My first use counters, which is concrete, then number line, which is pictorial, before moving to written algorithms, which is abstract. I know when you hear written algorithms, you'll be thinking, oh, that's a big grammar. Written algorithm are just the basic sums that we have. 2 plus 3 equals 5. 5 times 8 equals 40. Those are the written algorithms. All right, moving on to stage one, the concrete stage, which is the hands-on. At the concrete stage, children use real objects or manipulatives, what we call manipulatives, cubes, counters, base 10 blocks, fraction strips, and so on and so forth. This supports pupils in building mental images of numerical concepts, and it encourages exploration, it encourages play, it makes maths more engaging. I know for how would I call it, a Nigerian teacher will see all those manipulative and the real object as just play. It is not just play. It is a way of engaging children, helping them to build mental images of numerical concepts. Do not push, do not rush pupils away from this stage. Don't rush them. Depth of understanding, that's what we call conceptual understanding. Depth of understanding matters more than the speed. Once they understand the hows and the whys, the speed will not matter, because once they understand the hows and the whys, it will enhance their speed and fluency. Now at the stage two, the pictorial stage, which is the seeing maths, seeing it in form of pictures. pupils draw or use diagrams to represent math problems. To represent math problems. Now, at this stage is a crucial stage between concrete experiences. It links the concrete with the abstract. Can you please mute your mics, please? I need everyone to mute their mics. Thank you. All right. So at this stage links the concrete stage to the abstract stage. Now, common models of the pictorial stage includes bar models, number lines, arrays, part whole diagrams, division, and number bonds. For instance, if you give your child the problem 12 divided by 4, the students can draw 12 circles in groups of 4. Number lines, arrays, pattern diagrams, division, and number bonds. Can we please try to mute all mics, please? Thank you. So we're talking about giving a child a problem of 12 divided by 4. To use an array, the child can draw circles right at the pictorial stage. Draw circles, 12 circles in groups of 4s, making it look like an array. And that array helps the child to find the solution to that problem. So the abstract stage is the stage 3 of the CPA, and it helps the children to transit from the formal written method, transit to the formal written method. Once they have a secure grasp of the concrete and the pictorial stage, transitioning to the formal written methods, which are the algorithms or sums or equations that we see. Once there's a link, that's when what we call conceptual understanding happens, which is the essence of this module, numeracy 301. And once conceptual understanding happens, fluency at this stage is directly dependent on the solid conceptual foundation built in the earlier stages of concrete and pictorial. So, misconception warning. If pupils jump straight to abstract method, they may memorize steps without understanding the underlying meaning. E.g., adding zeros in long multiplications without knowing why. Adding zeros, like after the first set of, when you multiply the units by all the numbers, all the digits in the number given, then you needed to add 0 before you continue multiplying with the second digit. The children need to know why. They need to know why and how you arrived at, you got that 0, which is the conceptual understanding. Now, putting CPA together, a journey, not a ladder. Now, the definition and explanation is self-contained content. Examples illustrating practical application. Key points: deepening understanding and addressing common issues. Let's look at concrete. Concrete means manipulatives and objects. Pictorial, drawings and models. Abstract, symbols and equations. People should move back and forth between these stages as needed. It's a cycle of understanding, not a one-way ladder. Some pupils may need longer, to stay more at concrete stage to be able to gain conceptual understanding. And some pupils may need to stay longer at Victoria to gain conceptual understanding. Or some pupils may even do well at abstract. So they need to move back and forth in this. It's not just a one-way ladder. Fluency comes from flexibility and deep understanding, not just running through the stages. CPA in action. Let's consider this example. Addition 23 plus 15. Now, looking at the concrete stage, you can see 23 over here. At the concrete stage, we see the use of blocks. At the pictorial stage, we see the use of place value. And at the abstract stage, we see the use of a written algorithm. Now, at the concrete stage, you use base 10 blocks to represent 23. 20, 2 tens plus 3, and then 1 10 and 5 ones. Physically, you combine and count these tens and ones together. Then at the pictorial stage, you can draw place value charts or bar models to visualize the numbers and the process of regrouping if necessary. Then we move on to the algorithm stage. Once the students understand the concrete and the pictorial, finding the answers for the algorithm is easy. Children who visually understand regrouping with blocks and pictures make fewer errors when performing sums with regrouping. Regrouping is the same. Another word for regrouping is renaming. Then the usual word that we use in our local schools is what we call carrying. So, but the original names are renaming or regrouping. So people, when you use bar models or you use the base 10 blocks or the place value charts, when you use them in your addition or subtraction, especially when regrouping is involved, renaming is involved, or carrying is involved, the children make less error. The issue of, why did you forget to carry one, will not keep arising. Now, look at CPA in action when it comes to fraction. Half plus quarter. Now, in the picture, we can see a representative of half, a picture representing half, and a picture representing quarter. Using these physical fraction strips or cut paper into halves and quarters to physically combine and compare them for them to see the answer. When you combine half and a quarter, the children can see that the answer will be 3/4. Then next, you draw a bar model. You can see an example of a bar model here. You can use circles as well. You can use circles to represent it. You can use a picture of a pizza to represent the equation, in order to help them to visually show their sum. After which, they move on to the abstract equation, which is half plus quarter, which will give you 3/4. Always ask your pupil, how does your model show math? This reinforces connection between the two stages. How does your model show your solution? There are common pitfalls that we need to avoid in implementing our CPA, which is concrete, pictorial, and abstract. You need to avoid rushing to abstract too quickly. By bypassing concrete and pictorial stages, hinder deep understanding and create gaps. Then you see that a particular number of your children, or a particular group or learning ability of your class is making a particular error that you need to keep redressing from time to time with the use of mini plenaries all because you had rushed too quickly to the abstract. Now, treating manipulatives as just play. Manipulatives are structured tools for learning. They are not just toys, they are purposeful use of manipulative is key. You're not just giving them the manipulatives to play with, you show them, you model to them how to use the manipulative, especially it must definitely be tied to the topic you are teaching. It's supposed to be directly tied to the topic you are teaching. Then you use it, you model it, and then you give them more examples to practice. Don't treat the manipulative as just play. Then using confusing models. Models should clarify, it should not complicate. Ensure the model you have chosen, the concrete method or the pictorial method you have chosen, suits the topic you are teaching correctly. Don't use a model that will now scatter even the knowledge that the children have before, will make them lose it. Now, failing to revisit CPA. When pupils struggle with abstract concepts, feel free. Yes, it's true. You have started from concrete, you have moved to pictorial, and then you are now at abstract. When you still see they are struggling, feel free to go back to the concrete or the pictorial as the case may apply. CPA is not baby maths. It's how deep and lasting understanding is built across all ages. So why does CPA matter? Number one, step-by-step concept delivery. It helps show the children the flow, the gradual increase in which their learning increases. It provides a clear structured way to introduce and develop maths concepts. And the concrete is like the foundation. Then you build on the foundation with the pictorial, and then you crown everything with the roof, which is the abstract. Now, the CPA also builds resilience in learners. Mistakes become valuable learning opportunities when students can visualize and manipulate concepts. Once they can visualize and manipulate concepts, it is very easy for them to problem solve because they want to go back to it and know what mistake they are making and to figure out their answers and the mistake they are making. Why does CPA matter? Another reason is visual and it is visual, it is interactive, and it is memorable. Children will not forget what they have done. Children will not forget what they have done. Then the CPA matters because it supports all learners. You have G and T's, that is the gifted and talented students in your class. It definitely helps them. You have the students who are struggling, even the child who cannot read. The CPA approach caters for all learning abilities. It's beneficial for high achievers, it's beneficial for your SEND students, it's beneficial for your EL students. So CPA it's not optional actually. Most teachers treat this CPA approach as if it is optional. It is not optional. It's foundational pedagogy for effective numeracy teaching, and it fosters a love for maths. When the children are able to move from concrete to pictorial to abstract, it makes them love maths. They look forward to that part of maths. It fosters the love for maths. Now, why use visual representation? The power of models in mathematics. It makes invisible thinking visible. All those abstract processing in mathematics, you can even just looking at your students working with the manipulatives, you can see how they are processing the concept. It helps you to be able to measure the thinking of your students, to get into their heads and see how they think. It bridges the concrete too abstract. It creates a pathway from hands-on to manipulation to mathematical understanding and symbolic representation. Multiple entry points is another reason why visual representations matter. Multiple entry points accommodate diverse learning styles by offering visual, spatial, kinesthetic approaches to mathematics. Then it connects topics. It helps people see the relationship between math concepts like fraction, division, multiplication, addition and subtraction, and so on. So models don't replace thinking, they support reasoning and make the mathematical concepts accessible to all learners. Now, what are the key types of visual models that we have in numeracy? An example every teacher should know. Number one, bar models. Bar models. After this training, find time to go into to the website and check for more supporting documents that will teach you about bar models. It will teach you about number lines. It will teach you about arrays, place value grid, part whole models. You can find all this and all their explanations and examples for you to practice. You find them on the calculation policies. They are there. Bar model in action. A problem. A rope is 24 meters long. One piece is 1/3 of the rope. How long is that piece? First, we draw a bar divided into 3 equal parts to represent the whole rope. Next, the visual insight. Each part clearly shows 8 meters when the 24 meters is divided equally. Then the abstract connection. The visual supports the calculation. 24 divided by 3 equals 8. The model helps people see division before they attempt to solve the problem numerically. From teacher model to student independence. Another key pillar of teaching of the CPA is teacher model. It is very important. The teacher needs to model and show the students how to use the manipulative, how to represent their songs in pictures, and then even the abstract. Modeling the abstract is also key. At every step of the CPA, teacher models leads to student independence. If you're moving towards model, you need to show the student clear step-by-step drawing with explicit thinking aloud and mathematical language. You will be showing them while using your math language, using the correct vocabulary to describe what you are doing. After which the pupils practice. The students copy and practice with similar problems that the teacher has done to build confidence and to build familiarity. After which they now independently create their own models. That's the step. It is 3 steps. The teacher demonstrates, the pupils practice it first, practice by imitating the teacher. Once they gain independence, they begin to create their own models for new problems without teacher guidance. Students no longer need the teacher to supply the representation. They become independent thinkers as a result of teacher model. Okay. Now, what are the pitfalls we need to avoid with visual models? Number one, wrong model choice. We said that earlier. Using a bar model when you could have used an array. That is why you need to get familiar with the calculation policy and know the models that are suitable for each each topic in mathematics. Overcomplicated visions, models that are too complex, cluttered, or distracting from the core mathematical area should be avoided. Mindless copying, pupils drawing representation. In fact, sometimes when some teachers are teaching fraction, they turn the class to an art class where the children begin to draw the shape and begin to divide the shape into. Yes, you want to use models, but please don't turn the class to an art class where they have to draw the pizza, where they begin to draw the grid. Yes, there's a place for that, but in order to help the children get there, you want to do visual models. Why not make these models available? You can draw them yourself and present them to the children. Then why are the children drawing things without understanding what they are drawing, the purpose and the meaning? So mindless copying of models is a pitfall that we should avoid. Then limited variety. Try not this week you're using bad model. You've used bad model on Monday and Tuesday. If there is another model to use it on Wednesday. Just make sure it is appropriate and it will not cause confusion. It will not be complex and cluttered for the students. Why mental maths matter? Why does mental maths matter? Number one, mental maths matters because it makes room for fluency. It helps the children to have confident recall of number facts, and this mostly happens during the process of CPA. It gives flexibility, it improves reasoning, and it builds confidence in the students and takes away all the anxiety and fear of being assessed. Now we move on to number talks. A number talk is short and focused, a brief 5 to 10 minutes whole class mathematical discussion activity. You talk about the number or the concept you want to teach using the correct vocabulary, the appropriate, not correct, the appropriate vocabulary. Then number talks, the next step of number talk is mental calculation. People solve problems mentally, then share their thinking strategies. The number talks are strategy focused. The teacher records methods on the boards, not just the final answers. Then the essence of multiple pathways. Different strategies are valued, different strategies are discussed, and then eventually compared. You compare them for efficiency. Okay, which one is better? Which one is easier? Which one was faster? You compare the multiple pathways and then help the children build efficiency. For example, 18 times 5. The student thinking 18 times 5. A child could first of all think 20 times 5. And then minus 2 times 5. 20 times 5 minus 2 times 5. 20 times 5 is 100. 2 times 5 is 10. So when you take 100 minus 10, it gives you 90. And that's one of the pillars of the American curriculum. They encourage the children to try different multiple pathways in order to solve their sums, not just the one-way method. Effective teacher moves. The teacher should always encourage multiple solution strategies, like I mentioned, and mathematical thinking approaches. And how can you encourage it without modeling it? You need to model it. When you model a method today, model a method tomorrow, then on Wednesday, begin to compare both methods. Let the student begin to tell which one is easier, why this one is better, and all. Encourage multiple solution strategies. Encourage the children to also come up with their solution strategy. Record these strategies side by side. Visually display different methods to help students compare and contrast approaches. Use precise mathematical language. We are regrouping, we are partitioning, we are compensating, we are decomposing. Use the correct mathematical language for the model you have chosen. Sorry. Avoid judgment. Highlight efficiency and flexibility, rather declaring one method as better than the other one. Then silence is powerful. Give your children adequate wait time to think before sharing their strategies. Let's see number talk in action. Looking at the picture, looking at our slide, we have 52 minus 19. There are multiple solution pathways to solve 52 minus 19. Can everybody do that in the chat box now? Can you give me at least two pathways to solving 52 minus 19? So let's see. Let's have your responses. We have 1 minute. I am expecting responses, please. 52 minus 19. Can you suggest a pathway to solving it? Okay, when you suggest the pathway, can you write an explanation how you arrived at that pathway? Quickly explain it. I can see Neka Philomena already responded. 19 plus 43. How did you arrive at that pathway? I'm still expecting responses. Okay. 15 minus 10. Good. 2 minus 9. Really? How did you arrive at 2 minus 9? Okay, minus 7. Good. Use of negative numbers. 40 minus 7. 33. Beautiful. I love this pathway. Well done, Mide. Thank you. Let's have more, please. All right, is anybody contributing? Okay. I have 50 minus 10, 40. Okay. 50 minus 10, 40. 40 minus 9, that's 31. Beautiful. I love this pathway too. Well done. Xiaomi. Well done. Thank you. All right. Let's move on. Now, possible student strategies. We have compensating strategies. What does it entail? I think none of us even did that. 52 minus 20 equals 32. Then add back 1 to make 33. So to solve that sum, 59 take away 19, we added 1 to 19 to make 20, so that it will be easier to just take 20 out of 52. 52 take away 20 gives you 32. Then you add back the one you took away, which gives you what? I mean, you add back the one. You took away from 53, yeah, which now eventually gives you 33. Beautiful. I can see responses are still coming in. Well done. Now, another strategy you can use to solve that is the partitioning strategy. You partition it. I know somebody did this partitioning strategy. Partitioned both to lovely. In fact, that was Mide's strategy. You might not know the name of the strategy now that you used, but now you know. Partitioning strategy. You think breaking apart both numbers by place value and then bringing them together after you have gotten your solutions. Another strategy you could use to solve that is bridging strategy. 52 take away 20 equals 32. Then I add 1. This bridging strategy involves rounding the number to make the calculation easier. So which strategy is most efficient? And why might students prefer different methods? Can we answer this question in the chat box, please? Which strategy do you prefer most between the compensating strategy, bridging strategy, and partitioning strategy? Which one would you prefer most? And why do you think students will prefer different methods? Why do you think students will prefer different methods? I'll be counting down from 20 to get your responses. I just need answers from the first 3. Partitioning method, Mr. Sam. Thank you. Okay, Philomena thinks partitioning strategy will be better. Please try not to label any method as a better method than the other. Let the children be the one choosing. Let the children be the one, making their choices. Not because it's better, but because they find it more, appealing to themselves. Okay, yes. It's not that it's better, but you prefer it. Lovely. You prefer bridging strategy because it will be easier for the student to do simple addition and subtraction at ease. Good. Partitioning strategy. Somebody else prefers that. That's Mr. Warif. Mr. Warif prefers the partitioning method. All right. So what? But the second question is why? Why do you think the students will prefer different methods? Why do you think students will prefer different methods? Can we unmute our mics, please? Why do I mean even another question? Why do you think students will prefer different methods? Why? Okay, Eunice prefers bridging method. So why do you think students prefers different methods? Being exposed to different methods, then yes, I love this response to enable them choose the one easiest for them or the one they prefer, the one that appeals to them, because the way you reason differ. Yes, beautiful. I'm just going to move on from here. So, common pitfalls we should avoid. Let's not forget speed over understanding, single strategy focus, missing the connections between the concrete, the pictorial, and the abstract. And finally, neglecting language. Mr. Sam, thank you. Students will prefer different methods because their level of understanding differ. Good. Different methods for different levels, higher, middle, and lower. Beautiful. Thank you, Mr. Sam. Let's not forget the common pitfalls we should avoid. Speed over understanding, missing connections between concrete, pictorial, and abstract. Focusing on one single strategy, avoid it. Teaching tense and unit from Monday, tense and that is the written method, teaching it from Monday to Friday, avoid it. It will not help fluency. Then, neglecting the correct language you are supposed to use. Thank you, Ms. Akinyosola. We're rounding up already. I'll be done in another 2 minutes. So, building strong foundations. The power of calculation policy. We will explore how robust policies are essential for fostering mathematical understanding. Why calculation policies matter: progression of methods, consistency across year groups, CPA stage connection, and shared language, so that across the school, everybody is using the same language, the same we are all on the same page on the methods to use for teaching a particular topic in mathematics. That's why calculation policy matters. So the policy in practice, example, EYFS, counting objects, grade 2, partitioning numbers, grade 3 to 4, expanded column method, grade 5 to 6, compact column method with regrouping, and so on and so forth. So you need to balance. However, we need to balance the calculation policy and our professional judgment. We understand. Can we unmute mics, please? We understand our students, so we need to use our professional judgment when a child is stuck or when the child is racing ahead.
When I start, you will sleep outside, though.
Can we unmute our mics, please? All right, key takeaways. The CPA approach, visual representation and model, mental maths and number talks, calculation policy, and technical skills. So action for English executive. One CPA lesson this week. Use at least one new model in your next maths class. Run a 5 minute number talk with your videos. Make maths visible, make it flexible, and make it accessible for fun. Thank you so much for being part of this lesson. Mr. Yosolan, that's it for us. Thank you.